So given this vector field, capital F of x, y, z is 2xyz plus 3y squared, x squared z plus 6xy, and x squared y plus 5. Prove that that vector field is irrotational and find the potential function. Well, to prove something is irrotational, we have to show that its curl is zero. So recall the strategy we had for curl. The curl of f was simply the cross product of the del operator with that function f, the del operator being partial with respect to x, comma, partial with respect to y, comma, partial with respect to z crossed with f. So let's build our matrix of interest here to find the curl. So ijk across the top, remember it goes plus minus plus. Second row, partial with respect to x, partial with respect to y, partial with respect to z. And then we have our equations here. Of course, I've got to change that z to a y. It's 2xyz plus 3y squared, x squared z plus 6xy, x squared y plus 5z. So now let's go ahead and do the computation. So we have curl f is plus I times his minor, which is partial of y of x squared y plus 5z, minus partial of z of x squared z plus 6y, then minus j. What do we have? Partial of x squared y plus 5z, minus partial of z of 2xyz plus 3y squared, plus k times partial of x squared z plus 6xy, minus partial of y of 2xyz plus 3y squared. So what does that give us? Curl f equals I with respect to y, x squared, minus with respect to z, x squared, so that's 0, minus j with respect to x, 2xy, minus with respect to z, 2xy, so that's 0, plus k with respect to x, 2xz plus 6y, minus 2xz plus 6y. And in z, indeed, the curl is the zero vector, which proves that this vector field is irrotational. Therefore, it is conservative. Therefore, it has a potential function. Let's find it. So there's our vector field, our potential function, little f. The gradient of little f has to equal big F, which means f sub x, comma, f sub y, comma, f sub z has to equal big F. So we'll start with the first piece. We want f sub x to equal this. We're going to try to reverse that process if we can. So if f sub x equals 2xyz plus 3y squared, what does that make f of xyz? Integrating with respect to x, it'll be x squared yz. And 3y squared is perceived as a constant. Multiply that by x, that would be 3x y squared. But then we can add any function of the other two variables being what? Being g of y and z. So we get there. So next up, I want to take a look at f sub y. So f sub y would be the partial derivative with respect to y of my f of x, y, z, which is the partial derivative with respect to y of what I have written. So then f sub y would equal the partial with respect to y of x squared yz is x squared z. The partial with respect to y of 3xy squared is 3x times 2y, or 6xy. plus the partial with respect to y of g of yz is g sub y of yz. But what do we know? What is f sub y? Looking above, f sub y was x squared z plus 6xy. Well, that's kind of nice. So knowing that, then what do we have? We have f sub y is x squared z plus 6xy. So what does that mean? That means g sub y is going to be 0. So if g sub y of yz is 0, what does that mean? That means g of yz is just a function of z. G of yz is some function h of z. So let's try to find that. Focusing on this line and substituting g of yz equals h of z, we can rewrite what f of xyz is. Then we can take a look at the partial with respect to z of f. What would f sub z be? Well, that would be x squared y plus 0 plus h prime of z. But what is f sub z? If we go up to the top here, f sub z is x squared y plus 5. So that then tells me that h prime of z has to equal 5. So using that fact, h prime of z has to equal 5, which would tell me then that h of z is 5z plus a constant, but I'm just going to go ahead and leave the constant to be 0. So I get h of z is just 5z. So where does that put me now? Recognize we were here before, and we said f of xyz was x squared yz plus 3xy squared plus g of yz. And then notice what we said. We said g of yz was just h of z. So I've got to replace this g of yz with h of z, which is 5z. So finishing all that up, we get f of xyz, our potential function, is x squared yz plus 3x y squared plus 5z. Now let's check this by taking a look at its gradient. What is f sub x with respect to x? 2x yz plus 3y squared. What is it with respect to y? F sub y is x squared z plus 3x times 2y, 6xy. What is f sub z? With respect to z, we get x squared y plus 0 plus 5. So what would my gradient of f be in that case then? My gradient of f is 2xyz plus 3y squared, comma x squared z plus 6xy, comma x squared y plus 5, which you will notice all the way on the top that these match. This starred is big F of x, y, z, and this is the gradient of f, which concludes that f is the potential function for this irrotational vector field, which is conservative and a gradient field.